So in the last video, we did some definitions about experiments. Now we're going to talk about how we actually design an experiment. So the first thing we need to do is identify the problem we want solved. So the statement of the problem should be as explicit as possible, meaning we should provide as many details as we can and should provide the experimenter with direction. The statement must identify the response variable and the population we intend to study. This statement is often referred to as the claim. Next, we determine the factors that affect the response variable. And factors are usually identified by an expert in that field of study. And they're usually found by asking questions like, what things affect the value of the response variable? So if we're talking about high blood pressure, what things can affect blood pressure? Well, stress, exercise, underlying disease. So we would list all the things that could affect whatever we're looking at. After we identify the factors, then we determined which ones are set at a fixed level, meaning we keep them constant, they don't change throughout the experiment, and which ones we're going to manipulate or change, and which we're not even going to try and control, meaning we kind of ignore them. So the next step then, after we figured out all the factors, is determine how many experimental units we need. And remember, experimental units are subjects when we're talking about people. So we want to choose as many experimental units as we have time and money for. And we'll discuss a couple ways to decide the smallest number of people we can get away with when we get to Chapter 9. So the next step then is determine the level of each factor. So there are two ways to do that. One is control. And in control, we set the level of a factor at one single value throughout the experiment, and we never change it. You do that when you're not interested in that variable's effect on the response variable, but you know that it does have an effect. So if you set it at one value, then everybody has that level of that factor, and you won't notice it affecting the response variable. You can also set the level of a factor at various values. And that's if you're interested in that variable's effect on the response variable. So the combinations of the levels of all varied factors constitute the treatment. So let's say I'm trying to determine the most optimal dosage of a certain medication. Well, I might give one group 5 milligrams daily. I might give another group 10 milligrams daily. I might give a third group 20 milligrams daily. So that would be setting the level of the factor that I'm interested in. What amount of the drug should people be taking? And I've done it at various values. So the other way to deal with the factors is by randomizing. And that just means you randomly assign experimental units to treatment groups. So that method mutes the effect of variation attributable to factors that are not controlled. So if I want to study the effect exercise has on people, I will just, some people exercise more than others. Some people eat differently. I would just randomly assign people to the different groups. And that way, someone who eats more healthy food and someone who eats less healthy food might be in a group together, and so their diet gets washed out, essentially. Okay, so after you set the levels of the factors, you have to conduct your experiment. So several things when we conduct an experiment for it to follow good scientific procedure is there must be replication. And replication occurs when each treatment is applied to more than one experimental unit, which ensures that the effect of the treatment is not just due to some characteristic of that individual. So that's why you want to have multiple people in each group. The other thing we need is to collect and process the data, of course. And ideally, you should publish that data so that people can check your math, etc. So the way we do that, of course, is just measure the value of the response variable for each replication, meaning for each individual in the experiment. And then you organize the data. And Chapter 2, which we'll be tackling next, teaches us about ways we can organize data using tables and graphs and that kind of thing, charts. So the idea is that the value of the response variable is the same for each treatment group before the experiment due to randomization. And any difference in the response variable after the experiment is due to the treatment. And the last thing we do in an experiment is test the claim. So remember, the claim was that thing we were trying to answer, our problem to be solved that said what the response variable is and what population we're studying. And this is where we use inferential statistics. Remember, there are those two types of statistics. There's descriptive, which describes the data we have. And then there's inferential statistics, which we use to generalize the results from our sample to the whole population, and we give a level of confidence about that generalization. So there are two types of experiment design that we'll talk about briefly, and then we'll look at some examples in the next video. So a completely randomized design is one in which each experimental unit is randomly assigned to a treatment. So I put everybody's name in a hat, and I say I have 100 people and I need 2 groups of 50. So I put everyone's name in a hat and I randomly pick out 50 people. And I put them in one group. And then the other 50 go in the other group. Or something equivalent to that. The other is what we call a matched pairs design. And that's one in which the experimental units are paired up. And the pairs are selected so that they're related in some way. In a matched pairs design, there can only be 2 levels of treatment. So one individual in the pair receives one treatment, and the other individual receives the other treatment. An individual can also be matched against him or herself. So the matched pairs might be like a before and after for the same individual. Or it could be, okay, the husband has this characteristic. Does the wife have this characteristic too? Then the matched pair would be the husband and the wife. All right, that is it for this video. As I said, we'll pick up with some examples in the next video.